Hi there, my name is Eugene. I'm a second year engineering student. One of my subjects is called Applied Mechanics, and I will be going through a problem in my textbook with you guys. Now, on your screen, I've done a sketch, and in the textbook it says the following. It says, find the load in each section of the cable system in the figure. Now, I'm dealing with statics, so in statics, we will start with the forces that are known, and we will focus on that portion of the given system. Now, as you can see, we've been given a 12 kilonewton force acting downwards, which is supported by a cable, and the cable is fixed to in one end to a wall and on the other end to a wall, but the cable is also supported by some sort of structural member right here. Now, we have got the 12 kilonewton force. We were given this, and we will therefore start at point B. On your screen you can see that I've already drawn out a free body diagram of point B. Here we've got our 12 kilonewton force acting downwards. We've got the rope pulling to the left, and this portion is called BA, and this portion will be called BC, and there is our point B. We were given the slope of the cable. We were not given this 5, but using the theorem of Pythagoras, I was able to figure out that this hypotenuse over here is 5, because 4 squared is 16, 3 squared is 9. 16 and 9 gives us 25, square root of 25 equals 5. Now, moving along, we will use this information to figure out what BA is. Now, using the three equations of statics, which says that the sum of all the forces in the x and y direction needs to equal to 0, and also the sum of the moments about any point in the system need to equal to 0. Using that, we will be able to figure out what the tension in these two parts of the cable is. Now, we will start off with the forces in the sum of the forces in the y direction. I actually did this the wrong way around, sorry about that. Let me just switch it around. There we go. Now, we will start off with the components of the forces of BC in the y direction, for the simple fact that we have only got two y components in this free body diagram. We've got the y component acting at 12 kilonewton downwards, and then we're going to have a positive y component acting upwards, which we're going to figure out, or which rather we're going to use to figure out for BC. Now, using the method of similar triangles, we can say that BC in the y direction equals 3 divided by 5 times BC. So we're going to have 3 divided by 5 multiplied by BC is equal to BC, or rather the y component of BC, minus the negative 12, which is acting downwards. Remember, downwards is going to be our negative direction, and this equals to 0. Now, using a little bit of algebra, we will find that BC equals to 12 kilonewtons. I'm sorry, 20 kilonewtons. Now that we've figured out what BC is, we can use that to figure out what the tension in the cable at BA is. Now, the same law will apply, but we will be only dealing with the x direction now. Now, 4 divided by 5 times BC is also equal to BC in the x direction. 4 divided by 5 times BC by method of similar triangles equals BC in the x direction. Now to the right will be positive and also forces to the left will be negative. So we've got BC in the x direction, positive, minus BA, which is putting to the left, equals to 0. A little bit of algebra gives us 16 kilonewtons is equal to BA. Now we've solved for BA and we've solved for BC. Looking at the biggest section, we've solved for BA, we've solved for BC. Now we will be doing a free body diagram of point C. I've already done it, so let me just zoom in. Remember, we figured out that BC equals 20 kilonewtons. Same thing over here. We only had the 5 and we only had the 12. Using Pythagorean theorem, I was able to figure out that the hypotenuse for the small triangle is 13. We need to do this in order to use the method of similar triangles to figure out what CE is. Now we'll be looking at the force components in the y direction to figure out what the force in CE is. Remember, CE is like a stick holding the cable up, so it will be a compression force. Using methods of similar triangles, we can see that 12 divided by 13 times CE is actually equal to the y component of the force inside of member CE. As you can see, I've shown it over here. 12 divided by 13 times CE is equal to CE in the y direction. I just paused the video and I thought to myself, maybe I should do a small equation that shows you guys exactly how I got this 12 divided by 13 times CE equals the y component of the force inside member CE. And this is actually where it's coming from. If I've got a triangle, let's do it in this direction. Doing it for no reason. And I've got another triangle. And let's say I've got A. Remember, this A is for the small portion. Then I've got X. I've got Y for the larger triangle. And let's say over here I've got B. Now, where this is coming from is the method of similar triangles state that A divided by B is the same as saying X divided by Y. And you can check it for yourself. It actually works out. Now, if I add the third side of the triangle, let's call this side Z, and the hypotenuse of the smaller triangle C. So remember, the Z goes with the longer or rather the larger triangle, and the C goes with the smaller triangle. It is also the same as saying, let's say for instance, A divided by Z is equal to I'm sorry, I think I just made a mistake. A divided by C is equal to X divided by Z. And so you can go on with this and say, never mind, this video is going to be too long, but you get what I'm saying. So this is where this comes from. The CE just gets carried to this side. We've got 12 divided by 13 times CE equals CE, or the Y component of the force acting on CE. Anyhow, using a little bit of algebra, we can solve for CE. It's 13 kilonewtons, and this member is going to be in compression. Now moving along and solving for CD, we will be looking at the force components acting in the X direction. Now CD will be moving or acting to the right, so CD will be positive, minus BC in the X direction, method of similar triangles. I just spend a hell of a lot of time showing it to you guys. Minus CE in the X direction, so we have minus BC in the X direction minus CE in the X direction is equal to 0. But we have already solved for BC and we have already solved for CE earlier, as you can remember. There we go. Substituting in the values for BC and CE and working out the little bit of mathematics there is, we can solve for CD. Now, I believe that we are done because we've solved for AB, we have solved for BC, and now we have solved for CD. Thank you very much for watching. I hope I did okay, and yeah, good luck to all the students out there. I know that the videos out there have helped me a lot.